So can you hear me?
Yep, I can hear you.
Are we having technical difficulties?
No, not at all. I'm just waiting for folks to join. I figured we'd kind of come on screen top of the hour and maybe chat about the weather or something like that to give folks a few moments to
Sure. But
join.
Why would people come on and then jump off?
I'm sorry?
Why would folks come on and then jump off?
I don't know. Good question.
Okay. All right.
Maybe they wanted to go get some coffee or
Sure.
something. Like I just made myself.
So they're connecting with Zoom.
Yeah. This is my fifth cup of coffee right here. So
got my peach water right here.
What do you got? You got water? I got water.
It's water, but it's like a very hint light flavor of peach. Which I love peach.
I like, I'm really into, speaking of, is it like a sparkling water, like a flavored?
No.
Water?
Still, I don't like sparkling water.
Oh, really? So
it's still water. It's Fruit 2.0.
I'm a huge fan of these guys. I didn't realize this user group was going to be for advertising our favorite beverages, but these are great. I like the flavor, and they got caffeine in them too, which is always a plus. Yeah. I like the flavored waters, the infused, I guess, waters, whatever.
I generally don't require caffeine.
You require caffeine?
I generally don't require caffeine.
Oh.
I have enough jittery nerves on my own. But I do occasionally like a nice coffee or, I'll drink a Coke, but not like I used to.
Yeah.
I used to drink Coke like daily.
For those folks joining, feel free to make a comment or question in there. We're going to try to do a giveaway today for 2 of our little neoprene Cosmos DB coasters. Also, I may very special as well. I've got some of these guys as well. So there's these little stickers that look really good on your laptop or on your friend's back. So put comments and questions in the chat for our user group today, and we're going to try to use a feature in this tool StreamYard that says you can pick a winner out of this thing. So I'm going to try that sometime during your talk today, Lenny. So learning new stuff, growing pains. I use StreamYard every week, a couple times a week sometimes, but it's the first time I've done it doing a user group. So, all right. Well, we're near the top of the hour, but I would like to give people a few more minutes just to join. Yeah, I'm excited for Ignite coming up here in a couple of weeks, getting very close. I'm going to do a Learn Live session with a guy on my team, this guy, Gary Hope. And we're going to talk over or do a live presentation of a Microsoft Learn module that we created around the modeling and partitioning thing that is kind of an evolution of Thomas's talk from 2019, I believe it was. And I know we've iterated over that design a few times in that content, but now we've got it in a Learn module, I guess you call it. And so they've got this new format where you basically walk through the lab live, like a presentation, and then go and do the knowledge checks on there, which is kind of cool. And then you actually go live and do the exercises in there. So you provision the sandbox and all that stuff. So great. We've got some folks with us today. Hi, Will. Good to see you, my friend. And Tomas, good to see you. Yeah.
From Berlin.
Yep. Yeah, I've got to figure out how.
Early for some of you. It's later for others.
I know. It's like Will is in New Zealand. You got Tomas in Berlin.
I'm seeing the comments fly by really quickly. So I'm
sorry. I'm turning them on and off. So I'll put them on if I've for questions, Lenny, during your our meetup today. I'll leave them on there for quite a while for questions. How would you like your questions served to you?
As long if you're bursting to ask a question, I don't want you to feel like you can't throw it out. But ideally, I mean, this should go for 75 minutes, and then we should have 15 minutes for Q&A. So, which is, I think, plenty of time. Well, now 13 minutes for Q&A. The quicker we kick it off, the better.
All right. Well, I think we've got a little pretty decent gathering here. So why don't we kick that off? So welcome, everyone. This is our second meetup for the Cosmos DB Azure Cosmos DB Global User Group. It just rolls right off the tongue, doesn't it? But we're Microsoft, so we know how to name stuff. This month, we've got Lenni Lobel, longtime data platform MVP, longtime Cosmos DB user. You've done everything, I think, Lenni, from just content creation to consulting to everything. Basically, you've been a good friend to the team and given us lots of feedback over the years, and it's great to have you with us presenting this month. This should be a really fun. I promoted you during the podcast, the Cosmos DB podcast, right over there. So hopefully we got some additional boost there from you. So anyway, good to have you. I will hand it over to you, my friend.
Well, it's good to be here, Mark, and thank you for that wonderfully warm opening and introduction. I greatly appreciate it. It's been a long-time fan of Cosmos, and I'm really happy to be here presenting tonight this presentation, Building Event-driven Microservices with the Azure Cosmos DB change feed. Bit of a mouthful there. The two points being microservices and change feed. That's what we're talking about tonight. So I will start off by saying that this is somewhat of an advanced session, but having said that, even if you're new to Cosmos DB, I'm going to make sure you'll be able to follow along, because we're going to review at least the most fundamental concepts in Cosmos DB, which is really hard to have any kind of conversation about Cosmos DB without at least discussing, to some extent, partitioning. I mean, that's really the core of what it's all about, along with other things, but partitioning is the big one here. So we will review that. For those of you that are newer to Cosmos DB, you'll be able to use that'll help you ramp up, and then we can talk about the change feed and what it is and what it can do for us. Namely, it makes it very easy for us to build microservices by consuming the change feed, and we'll see throughout the session how to apply these concepts to real-world scenarios and build event-driven microservices for retail and IoT and other really large-scale scenarios, event-driven scenarios. All right, so let's just jump in and talk about the change feed. Every Cosmos DB database has one or more containers where you store JSON documents. And every time you store or update a document in that container has a change feed that emits that change. And that opens the window for a whole set of possibilities and scenarios, including replication. And I'll talk about what I mean by that in a moment. Denormalization, which comes up when you are building relational models in the nosql world. Notifications, any kind of interesting event that occurs can certainly be used to trigger a notification. Build materialized views so that queries that would otherwise be very expensive wind up becoming very cheap, because you're maintaining this materialized view for specific purposes and for specific queries. And certainly any data that's entering Cosmos DB can be picked up on the change feed and be used to push that data downstream. So kind of move that data to any other downstream system. It could be SQL Server, Azure Blob Storage, Oracle, I mean, anywhere, data lake, wherever, just moving the data. These are all scenarios that are very easy to implement. by listening in on the change feed, and you can implement them as event-driven microservices. And one of the great things about this architecture is that they all consume the same single event source. So you don't have microservices that are dependent on one another, and this makes for a much simpler microservices architecture overall, where you can have independent microservices, as you'll see, running, all consuming the same change feed, yet all independently maintaining their own state, maintaining their own scale, and performing their own discrete microservice function. So let's jump into that partitioning discussion real quick. We have to understand horizontal partitioning to understand how this works. A container is a single logical resource that we interact with, and we view it as a single container, but of course behind the scenes, there is a cluster of servers, or physical partitions, if you will. I'm using the term server loosely because each one does have its own CPU and its own disk storage, just like any box would. But in fact, physical partition is a more accurate term because each one of these is in fact a unit of replication behind the scenes in terms of redundancy. Even within a single data center, each one of these physical partitions is replicated at least 4 times. But for the purposes of our conceptual understanding, think of it like a box, a server, right? And there's really no upper limit to the number of members you can have in this cluster. And so therefore, theoretically, at least, there's no limit to the storage or throughput because you get more CPU and more disk storage each time you add another physical partition behind the container. Each time CosmosDB does it, because of course this happens automatically behind the scenes. So I use the term physical partitions and server loosely in the same manner. We don't really have to worry about them because, like I said, it happens behind the scenes. We have to worry about the logical partitions. So let's drill in now on 3 of these physical partitions. And we understand that when we write documents in the container, they're going to land on any one of these physical partitions. But it's not an arbitrary decision made by CosmosDB. CosmosDB is going to group the documents in each one of these physical partitions according to the partition key that you define, which of course defines the logical partition. So anytime you create a container, of course, you have to define the partition key. And every scenario is going to be different. I'm going to move into a social networking scenario, just for example, for the purpose of this discussion for the next few slides, where we have chosen the username as the partition key. And that would mean if we now at this point forget about the physical partitions and just concern ourselves with the logical partitions, each logical partition holds documents belonging to one user. But each of these documents are of different types. Let me see if I can get my PowerPoint. It's supposed to, yeah, then my laser pointer. Okay, so this one here could be Tim's user profile. The next several could be posts that Tim created. And the next several after that could perhaps be comments that Tim has made on other users' posts, as well as these last 2 documents might be likes, where Tim has liked other posts. But basically what I'm saying is documents of all different types. But the one thing that they share in common is that username property that is what's grouping them together into the same logical partition. Okay. So let's have a look at some common partitioning patterns. If we go back just like a slide or 2 here, if you look at this partition key here that you're being asked for, you need to understand that in a container, every document is going to be unique across that entire container based on a composite that is a combination of this property, whatever you choose, plus a special property called ID, and it's always called ID. Right, so the ID property is only unique within a partition. It's not unique within the entire container. It's only unique within a logical partition. So if we look at some common partitioning patterns and we choose the ID property itself as the partition key, which may sound odd. Basically, what I'm saying is every document is unique based on the composite of the ID and whatever property you choose as the partition key. But if you choose the ID property itself as the partition key, you get this kind of key value store. You get this kind of like single document per logical partition. You know the key, you get the value, you get and set the value. It's perfect for single document reads and writes. Especially IoT scenarios where you're ingesting massive amounts of data, as you're going to see in demos coming up. It is the way you're going to get the most uniform distribution evenly across servers across servers in a cluster that expand automatically by Cosmos DB, right? Because there's no affinity. There's just every document goes into some logical partition. So it's perfect for these reads and writes where your primary use case is, I have a key, I need to get and set a value, and I need this thing to scale. Right? So it's perfect for that. Obviously, it's not going to be well suited for any kind of query where you want to kind of group documents together like we were looking at before, where posts and comments and likes can all be efficiently queried together in a logical partition. We're not going to get that here, but that's a different scenario. Not everything is big data. Sometimes you'll have some small lookup lists. Sometimes, and you will always have a great many of these small lookup lists to support your application. Like for instance, if you run an airline, all the flights that you run can fit in a single logical partition. All of the airports that you service can fit in a logical partition. If you're running a web store, all the product categories can fit in a single logical partition. And what application doesn't have a list of states and provinces for that dropdown, right? So these are all things that fit comfortably within the 20 gigabyte limit of a logical partition. You'll never come anywhere near that for these things. And for these things, it's very common to attach a type property and then set the value of that type property to the same value for every document in that type, and then group them in the same logical partition. So you could consume the entire list of flights or airports or states in one go if you want, very efficiently, because they'll always be in one logical partition. And you can always, of course, fine tune your query to narrow down, and it'll always be contained within the same logical partition. Other partitioning patterns, the list goes on, and if you attended Mark's excellent talk last month, he showed some scenarios where you optimize for queries. You look at your patterns and you say, what are my most common patterns? So for example, if you did go with customer ID, you would have a scenario like this where documents of different types, like you might recall from his session last month, customers and orders both contain in the same logical partition, and very much optimized for queries where the customer ID and you can get the customer and their orders all in one query. Furthermore, if the customer embeds addresses and the order embeds details, you can gather all that information extremely efficiently for those types of queries if you partition on the customer ID. Okay, let's get back to something that's really, really critical to understand, and that is the order to change events. So you're free to model your data any way you want in Cosmos DB. You can do it relationally, like the web store model from Mark's session last month, where it's kind of a stateful representation, like you might have in a relational database, but we've kind of adapted it for Cosmos DB with reads and writes and deletes. Or you can model things purely as events, and that's the scenario that we're looking at now. So take a shopping cart scenario, okay? Anytime something happens, it's always an insert. Even what has happened has been an update or a deletion. So any kind of event that occurs, the cart's been created, the first item has been added, the second item has been added, and then the first item got removed. But it's not a delete, it's an insert of a new document that represents the removal of item number one, and so on and so on. And naturally, of course, you can imagine if you have multiple microservices listening on the change feed, it's absolutely critical that these events get processed in this order. No matter what's going on behind the scenes in terms of the way Cosmos DB might be shuffling partitions around, at any point in time, you have to be able to say, I need to play these events in this order, and perhaps even rewind and replay these events in this order independently per microservice, right? So how is that achieved? Well, let's drill into the physical partitions behind that container. So one container, one change feed. Well, one container we know is multiple physical partitions, and in fact, each physical partition has its own change feed. That's really what's happening behind the scenes. Each physical partition has its own change feed, right? So if I start an event, create a cart as customer A, that's the first event for that cart, for that customer. And if another customer comes along, it's a different logical partition, because it is a different partition key, and Cosmos DB could easily choose to land that on a different physical partition. This time it has done it on the second physical partition, and so on. And then these events occur, of course, overlapping, interleaving as more customers come and enter the website and perform activities. It's going to grow like such. And each time you see that there is been a change made, let me just rewind that because I meant to talk through it as I was looking at it, as I was explaining it. When that first document gets saved, A1, it is also emitted through the change feed down here, as you can see. And the same thing for B1 and B2 and C1 and so on. And these are being emitted to the change feed in the exact order that they're occurring. So anyone listening is going to get them in the correct order. What's going to happen at some point in time is that some partition is going to become too full, meaning either too full from a storage perspective or a throughput perspective based on what you've provisioned. You might need more processing power, you might need more storage space, might need a new partition to be added by Cosmos DB automatically. And that will happen. You'll get a physical partition that will spin up automatically, and it will have its own change feed. And then roughly half of the logical partitions will move over from the physical partition that's being split. It's only one partition that's being split. I have a cramped slide here, but it would be more than one logical partition. It would be roughly half the logical partitions that move over. And at that same point in time, the change feed events for those documents will also move over with their order preserved. So cart B event 1 will always still remain before cart B event 2. And then life will continue, then more customers will come hopefully and shop until they drop. And you'll wind up with a picture like this, where you have like 3 change feeds now. So now, of course, we won't have to worry about the 3 individual change feeds in most cases. But if you do look at them individually, you will see that within each logical partition, the events are always in correct order. They're always being preserved. So even as Cosmos DB is splitting these containers in high volume and high velocity, your events are always going to be played in the correct order, which is critical, obviously. So now we've got these events, and like I said, we will have the benefit of the change feed processor library that we'll look at shortly. That will mean we don't have to look at this as 3 change feeds. We can look at it as one logical change feed. And the change feed processor library will parallelize across these physical partitions. But even as it does so, and you can see as they are interleaved, within each logical partition, as we consume a single logical change feed, per logical partition, we are getting the events in order. Within each cart, the events are always guaranteed to be in order. And it's kind of like a magical baked-in capability that you get with the change feed. How can you consume the change feed? Let me just do a quick time check. Okay, we're making a good. Hi, Alec. Hi, folks. Hello, everyone who's saying hello. Great to see you all too. So, consuming the change feed. How can you do it? Well, I mentioned this for completeness. You won't want to do it because if you do it directly, then you will have to consume 3 individual change feeds. You'll have to discover the partitions to discover that there are, in this case, 3 physical partitions. Visit each one, very low level, very getting your hands dirty, very rare scenario that you would have to drop to that level. There's also a poll model, which is scalable in that it will parallelize across the partitions, but in most cases, it's still not the recommended way to go. It's more of a manual polling, and you'll still have to maintain continuation tokens. It does have an interesting option if you do need to consume the change feed, but only for certain partition keys. Like you can specify the individual partition keys, which is an interesting capability that you might want to use the poll model for. But in most cases, you want to use the CFP library, the change feed processor library. It is both stateful and scalable. It is scalable, as in it will parallelize the workload across multiple threads, if necessary, to process multiple partitions. And it will also maintain in a special lease container. It's a container that's called a lease container that you'll see in a moment. It will maintain state. And so you just, you sit back and you can enjoy the push model. All right, and you sit back and the events just stream into your microservice. Now, Azure Functions is merely a serverless wrapper around the CFP library. It's like the easiest way to get started, and maybe the most fun way to get started because it's quick and to deploy and quick to get up and running. And that's what we're going to be doing. But really, each of these is just increasing levels of abstraction above the other. I mean, the Azure Functions wrap the CFP library, and the CFP library in turn is handling all the state and scale that you would have to if you were doing it directly or maybe using the poll All right. Okay, that is the overview. Now we're going to jump into, remember that slide a while back where I listed the replication, denormalization. I said I was going to explain what I meant by replication. We're going to go through all of those, all 5 of those. And we're going to be very demo heavy on the last set of 3. The first one I said is replication. So replication, I mentioned, each physical partition is replicated automatically. That's not the kind of replication I'm talking about. I'm talking about replication in read-heavy scenarios where you need to cure analysis paralysis, because you need to choose that partition key wisely, and you're going to pick it based on your most common querying pattern, right? But here's the rub. You can still only select one partition key. And what if you have more than just one very common querying pattern? I'm not talking about the occasional query that is a cross-partition query where it's not burdensome to fan the query out, because it's not, you're not hammering your application with those types of queries. Those are just kind of popping up here and there, and that's fine. Those cross-partition queries are fine. But what if you are hammering your application with 2 or more, let's just say 2 very common querying patterns? You are going to be in a catch-22. But the solution to that would be to build a replication microservice. That's really very simple to implement. It will synchronize multiple containers with the exact same data. The only difference is the data is partitioned differently in the other container. So for example, if I have a cart container and now I'm going back to a stateful relational model, okay, where there are inserts, updates, and deletes. And this is a stateful representation of a cart item. And rather than representing some event, excuse me, and it's partitioned on the cart ID, because that way, if it's partitioned on the cart ID, knowing an individual cart ID, I can get the entire cart, or I can filter down on that cart and get all the surface pros in that cart, or I can get all the items in the cart with a quantity greater than 5. I can run all those queries on the cart, all very efficiently, because I know the cart ID, right? With a query like that, because the partition key is known, the query gets routed to the logical partition. It happens very quickly and inexpensively. But what if I want to get all the surface pros across all the carts? And it's not just like an occasional query. It is extremely common pattern that is constantly hitting my application, where I need to get all of the items of a particular all of the cart documents of a particular item, like all the service pros across all the carts. Very commonly, I will want a cart by item container that, by listening in on the change feed of the cart container, will replicate that document over. Except the only difference is that it's going to be the item property that's the partition key. So now my application has 2 containers to choose from for the same data. And if it knows the cart ID, it'll choose the cart container. If it knows the item instead, it will use the cart by item container. I stress it's only if it's a read-heavy scenario, because obviously the overhead of the microservice, it has to be worth building the microservice and incurring the rights to keep the 2 in sync in order to gain the benefit of the having the same data available, partitioned differently. All right. In this scenario, processing updates and deletes is something you need to think about. Today, there is a preview out, but let's just talk about the way it is today. Interim updates are not retained by the change feed. So if the same document is updated multiple times, the change feed, if you were to rewind it and replay it, you're only going to get the latest one. Now, for the replication scenario, that's not going to matter. If for any reason we needed to blow away our replica and rebuild it from scratch by rewinding the change feed, we only need and care about the most recent update. But otherwise, this is something you need to be aware of. And deletes, well, they are not written to the change feed at all. So for a replication scenario, this does actually pose a bit of a challenge. Let's take this example where I've got the same document in both containers, and the quantity is 2 on the left, and it gets changed to 3 on the left. Well, the microservice will wake up and update the document on the right to be a quantity of 3. Similarly, if the quantity changes to 4, it'll update it to 4. But what if I now want to delete this document? Well, first of all, understand that the change feed only has the version with a quantity of 4. If you rewind it, you're not going to see the version with a quantity of 3. That'll be fine because you only need the latest version if we need to rebuild the replica. But when it comes time to delete it, we can't simply delete it from the card container because, like I said, it will not be picked up by the change feed. And therefore, you're going to have this orphan document in the other container, which you certainly don't want. So the answer to that is the TTL, time to live, is a special property. If you haven't heard of it, it's just like it sounds. It's how much time you have to live before Cosmos DB automatically expires the document, deleting it from the container. And 60 seconds is well more than you need because the change feed wakes up in near real time. Very, very near real time. And once there's a brief polling when things are idle, but once the events are streaming in, it is virtually in real time. And so 60 seconds is way more than you need, but we're giving a lapse here because, well, just playing it safe. What we're saying is that when the microservice sees an update that involves a TTL property setting, it knows to delete the document from the replica, and then within 60 seconds or 60 seconds later, Cosmos DB will delete the document from the card on the left. So I said that's the way it is today. There is a full fidelity change feed that is currently in private preview, where there are item logs and operation logs, where essentially the item log is the way it is today, inserts and the latest updates only, but it's an infinite retention. And there's no metadata associated with the changes and stuff. You just get a copy of the document. Whereas the private preview is now supporting this operation log, which will have all not only all inserts, but all updates and deletes, but of course with a final retention after 30 days, at least at this stage, and with additional metadata to letting you know, seeing the previous version and the type of operation that you don't get with the item log today. Okay. This is going to be familiar to anyone that was at Mark's excellent presentation last month, because Cosmos DB, he was talking very much and explaining how Cosmos DB is non-relational. There are no joins, there are no relational constraints. Doesn't mean you can't handle relational workloads. It just means you need to do things differently. And one of those things is to denormalize, which means duplicating properties. We normally wouldn't do that. Normally wouldn't do that in a normalized model. Right? We're not going to be very normal about this. But we're denormalizing it in an effort to be able to now satisfy queries with a single request instead of multiple expensive requests. So his example, this is pretty much his example from last month, where you have a product document with IDs and you don't know the names, but you do is because the master data is in some separate container, let's say a metadata container. You would need to normally run these queries multiple times. Once to get all of the once on the product container to get all the products in a category, but knowing only the ID, it would be another query to get the category name. And then if you wanted the names of all the tags, it would be for each result from running this third query. That sounds painful, of course it is, and a bad design. So we would denormalize that and include copies of that master data at the point of insert. We would just put a copy of the category name and the tag names along with the IDs in each product that use those IDs, such that if on the left we had a microservice listening on the product meta container, and for a change in any master data, it gets replicated over, essentially cascading, like not quite like replication, but like similarly, you're replicating a property. You're not replicating an entire document, but it's conceptually similar. So if you change the name of a single category on the left from shorts to fun shorts, the microservice can cascade or change the tag name from outdoor singular to outdoors plural. The change feed can cascade that change across all documents on matching IDs. All right, you're probably getting hungry for demos. I know I am. So fear not, they're coming and they're cool. So let's go IoT. We're Contoso Airlines, very original. We're small. We only fly within the US. We only have 12 flights. We only have 6 airports, but we want to grow. So of course, Cosmos DB is the natural fit. And any airline would have these very basic requirements. We need real-time flight info. As these planes are flying in the air, we need that info. And there's some places that planes shouldn't be flying, so we need alerts if a plane never enters in the fly zone. we need to be able to provide clients with up-to-date arrival information, whether it's going to show up on an arrivals board in an airport or in some app. We need that information to be available and up to date. And we don't need to keep this stuff in Cosmos DB forever. So we also have a requirement to kind of, let's say the law requires us perhaps to permanently archive some of this information, maybe not at the degree of the very fine degree of intervals that we're receiving it, but every period of 10 seconds, perhaps, just we have to know what happened years and years ago. We'll want to move that off to cold storage, meaning less expensive stores than Cosmos DB, where it can always be retrieved, but it's not, the nature of IoT data is that its value is lost very quickly. Even 30 days is, a lot more than you need information about a current flight. When the plane lands, the data is already stale, right? So the solution, we're going to ingest flight telemetry. You can see that I've built a flight telemetry generator that simulates ingesting at a very rapid rate IoT telemetry data. And then we'll implement microservices, where it will generate email alerts if a plane flies where it shouldn't. It will generate materialized views so we can have our real-time flight information, our up-to-date arrival information available very quickly and cheaply, I should say. And quickly. And we will also archive the blob storage to handle that permanent archival requirement. All right, so we're going to start with a single container, the location container. And this location container is going to receive this flight telemetry very, very rapidly. And every time a plane, and then by that I mean every 10 milliseconds per flight, is emitting its speed, altitude, duration, it's a latitude, longitude, anything you think of, right, about that's of interest is being emitted, and we're going to consume that very rapidly. But we're going to put this partition in the ID property. If you recall, not too long ago, we were talking about common partitioning patterns, and for this scenario where you just need to scale and consume, you don't want to drop one document, right? We're going to partition on the ID property. It's going to give us exactly one document per logical partition, and as mentioned, highly optimized for bulk loading of IoT device telemetry, whether it's airplanes or microwave ovens or trucks, delivery trucks, whatever the case may be. And guess what? We're at our first demo, the flight telemetry generator. Let's first come on over to the Data Explorer and have a look at our containers. All of these containers are empty except the last two. The meta container has metadata in it. Look at the items. Remember I talked about the small lookup lists. So these are there's a small lookup list of airports, a small lookup list of 6 flights. This is what an airport looks like. This is JFK. Come on. It's just a small lookup list, and there's a type property that kind of logically groups each list. And then there's the location container. If I look at the location container, this is the one that's ingesting, or at least will ingest when I start the generator, all the flight telemetry. And this is partitioned on ID, and the ID is a GUID. So this is an example of a document that we're about to start ingesting very quickly once I start the generator. That has that GUID ID. The type is location. It's always good to have a type property, whether you need it or not. And I've said the type of location because this is a location. There's some static information about the flight that doesn't change from one document to the next. But then there's, of course, all the dynamic information, all that at that current point in time, right? What's the latitude, longitude, speed, remaining minutes, remaining miles, whatever. And this is a really important property because, at least in my little world that I created for this demo, this is going to be set to true once and only once when a plane lands, and you do not want to miss this event. So you'll often throttle events because you don't need to process each and every one, but you'll see in a moment, we're going to have to make sure that we don't miss this one because it's only going to get set once when the plane lands. And there's our TTL because we don't need to keep this around forever, and that amounts to 30 days is expressed in seconds. And these are just internal Cosmos DB properties we don't need to worry about. The lease container is going to be used by the change feed processor library. These other two, arrivals board and current location, those are going to be for materialized views that are coming up next. But now let's get the flight generator going. So let me show you what I have built here. Okay, I did this during COVID. So I had a little extra free time during a really dark period. And but I managed to build this kind of set of microservices. You can see there are 4 microservices that we're going to be looking at. And there's the generator. There is a desktop application, which is really the eye candy behind all of this. And then there's and then there's a shared project that they all share. So here are 4 microservices. I've got them up and running, ready to go. They're actually listening right now, but the generator isn't running, so they're silent. They're polling. And once the generator starts and they see the first document coming, they're going to stop polling. They're going to consume as quickly as the events are kind of happening. Right? But they're all going to be running independently in each one of these 4 console windows. And hopefully you can see in yellow, I got an email alert, a current location, an arrivals board, and a data archival microservice, all kind of listening and not doing anything because I haven't started the generator yet. This is the generator. I'm going to hit generate, and it's going to like simulate planes flying in the air. This is my eye candy. This is a WinForms application using the WPF Bing Maps control and WPF WinForms interoperability that was actually added recently. I know it sounds crazy. But anyway, that's what's going to give us our eye candy. I'm going to click Washington D.C. here. You see this red circle? That's our no-fly zone. We need to be alerted if a plane ever enters this no-fly zone. It's like a radius around, I think it's 500-mile radius around the center of Washington D.C. And where you can monitor all our flights, I'm just going to monitor these 2 westbound flights from JFK to LAX and JFK to Seattle. And they haven't taken off yet. They're sitting waiting to take off. Okay. All right. So let me get the generator going. Let's bring this down. Here. Let's get the generator going. I'll hit G for generate, and I'm going to hit -C for continuous, meaning as soon as the plane lands, it takes off. These planes fly very fast. It doesn't take 5 hours to get across the country. It just takes a few minutes. We're faster than any other airline, right? So let's get that started. And now the planes are about to be up in the air. Up in the air. There they go. There they go. There go the planes. There go the planes. Oh boy, they're entering that no-fly zone, aren't they? And you see the activity on all of the. There we go. And when you see it in yellow, I'm sorry it's so small. Let me see if I can make that bigger. Not quite. But there. Flight CA 1001 has entered a no-fly zone. Flight CA 1004 has entered a no-fly zone. All right. I'm going to show you that I've got in my Outlook inbox, I've got these 2 emails. I'm going to open them. They just came in. Nicely formatted in HTML. You don't need to see the rest of my inbox, right? Nicely formatted in HTML. You are receiving this notice because flight CA 1001 has entered a no-fly zone. And all the information about that at that point in time. So let's dig a little deeper. Let me stop the generator. I'm just going to hit escape. And the microservices are going to kind of go to sleep. And you'll see wherever you see yellow, it means something I've done has happened. We just looked at the email alert microservice, but we're going to look a lot closer at it next. We're going to actually look at the code. So let's get back to here. So what do we need to do? Like you just saw, we need to track all flights, constantly monitor every flight's location, and just run an alert when a no flight enters in a fly zone. How do we do this? We monitor the change feed, we examine each document, and we run a spatial query against designated no-fly zones. It's as simple as that. So we just really kind of saw that demo. The demo here is looking at the microservice itself. Okay? So that means jumping into Visual Studio and looking at some code. Remember, 4 projects, 1 per microservice. By the way, you could create 1 project and put all 4 microservices in it, but you want to do everything you can to keep these things isolated. Because what if you do that, what that means is simply that you have to deploy all 4 at once. If there's a bug in one, you have to deploy all 4. You want these things as isolated and independent as possible. And they're all consuming the same change feed, but they're all running at different paces, and they can all be individually started and stopped, and they will all individually maintain their own state in terms of the position they are up to in the change feed. And the one we're looking at now is the email alert microservice. So I'm going to pop that up. Actually, I'm going to first open local settings.json, because what you're going to see in each one of these is a local HTTP port. So I'm able to run all 4 microservices concurrently because I've assigned a unique port to each one. There's 7072, 7073, 7074 for the others. And so I can run them and debug them locally, which is an amazing thing. You can set breakpoints, and you can have them running concurrently or not concurrently. And when you're ready, just a quick publish to deploy. Very cool stuff. So let's have a look at this microservice, which is a little bigger than a microservice should be. And I'll talk more about what I mean by that in a moment. And let's, for now, just forget about these privates. I'll come back to them. Let's just have a look at this public static here called email alert. Actually, this name doesn't matter. This is the name that matters. The function name attribute is what makes this an Azure function. Without it, it's not an Azure function. And that's the name of the Azure function publicly exposed. Here's my Azure function, and this whole piece here is the CosmosDB trigger attribute, because an Azure function will have one of any number of different types of trigger attributes that causes it to fire. It could be when an Azure blob storage receives a file. Your code triggers. It would be a different trigger. A CosmosDB trigger means when there's a change on the change feed, specifically on this collection, which unfortunately, collection and container mean the same thing, right? Unfortunately, many of the APIs still call it collection, but that's a container. So what container am I watching the change feed on? If you look at the IntelliSense, hopefully it's really small. It's a constant. So it's the location container that we're watching in the Contoso Airlines database. Here's a connection string, which is again in local settings.json with my account endpoint and master key. That's the name of the container to use for state for the change feed processor library. It's not part of our model, but it's just there for state. We're going to have a look at that pretty much at the end of the session. And this is the lease container prefix, which again, we're going to look at these two things together, but this is what provides isolation across multiple microservices sharing the same lease container. You'll see all of our other microservices, they're all going to have a pointer to the same lease container, but they're all going to have a unique prefix. So documents in that lease container are scoped uniquely per microservice. And by convention, I'm naming it the same, just for sanity's sake. As far as parameters passed to your code, is actually only these two, which are the only two that you need. There's a read-only list of documents that have changed and a logger for you to write output. So do a quick time check here. Okay, we're good. So one thing you need to understand again is that the change feed processor library doesn't only maintain state for you in the lease container, it also maintains scale. It also parallelizes, meaning that this is not necessarily going to be all the documents that changed. If the change feed is being flooded with documents, multiple instances of this code are going to spin up across multiple threads. And so all the code that you write in your Azure function must be thread safe. And we're going to see that come into play as well. So it's just these two. I'm going to loop through all the documents that changed. I'm going to check the flat location. And it's nice to have a very high level try catch. I'm not going to talk much about catching exceptions, but you really don't want exceptions to occur in a microservice. And if they do, the best thing to do is to just usually stash it away in some queue somewhere to be processed later offline, and not to try to handle it in the microservice. Here, I'm not even doing that. I'm just logging an error to the console, okay? But you definitely need a try catch around each one. Depending on whether it's the change feed processor library directly or the Azure function wrapper around it, the exception will either be ignored, will either be swallowed or not. And it's just, either way, it's no good. You have to put your own try catch around there. So it's always good to have a one-liner inside that try block that does the work, right? So any exception will get caught. What am I doing? I am taking the document that changed. I am deserializing that object as a location event class, where you can see this is nothing more than a strongly typed C# class that reflects the document in the location container, the one we were looking at, with JSON properties for the camel case, but essentially, the latitude, the longitude, the speed, everything, basically the document, so that I can work with it in a strongly typed fashion in C#. Or if I didn't want to I could just say dynamic, and then I wouldn't have to have a class. So either way, I've got my location event, which has a latitude and a longitude double, and I'm going to call spatial is in no-fly zone. Actually, what is underscore spatial? I said I was going to go to the back of these privates. What are these privates? These privates, this is some business logic that has the spatial queries. And these are privates that really should not be in the microservice, because this microservice is just a demo and is actually not just detecting that a plane has entered the no-fly zone and therefore a notification needs to be triggered. It's actually delivering the notification, which is too much for the microservice to do. It's hard coded for email. It could be it could be SMS if you wanted. It's like it shouldn't be in the microservice, but it is. So SendGrid, if you're not already familiar, is a very easy way to deliver emails. It's a very easy to use service on Azure for sending emails. And in my config file, I've got a from email address, a to email address, and that's what showed up on the email that I got, right? And this one here, this is for these last two here are for thread safety, as you'll see in a moment. All right, so jumping back down to check flight location, I've deserialized the document that I got that has changed from the change feed into a strongly typed object I'm calling is in no-fly zone. If you peek at that code, it's like I said, it's it's 150-mile radius around Washington, D.C. So to calculate distance, and you're in the no-fly zone if you are within the allowable radius. And that's all there is to that, right? And in the real world, you consume polygons from a database of no-fly zones, right? And you would have intersection queries, but this is just a demo. So that's how that works. So what are we doing with each event? If the plane is not in a no-fly zone, we let the event fly by, no pun intended, right? We don't care. We're not stashing it anywhere. We're not storing it anywhere. We're ignoring it. So if it's not in the no-fly zone, we simply ignore the event. We simply return. Otherwise, I'm getting these events every 10 milliseconds. I do not want an email every 10 milliseconds. So we're going to throttle. We are going to throttle. We're going to basically say every minute. When you enter the no-fly zone, you get a notification. If you remain in the no-fly zone for more than a minute, you'll get another notification, and a minute after that, as long as you remain in the no-fly zone. And we're doing that with a thread lock. It can be done any number of ways in C#. It could be a concurrent dictionary. It could be a slim semaphore. I'm just using a simple thread lock to ensure that this code in here is executed in totality by one thread at a time. So in between the time you get a value or check for the location, or check for the existence of a key, and the time you either add or update the value, another thread doesn't come along and mess things up. That's it. So basically, if I hit line 73, I'm in the no-fly zone. But since the last email was sent, which is in my dictionary, I'm storing it in my dictionary. If it's less than a minute, I'm still going to ignore the events because I'm not flooding an inbox. Otherwise, if it's the first time, I need to do the add. Otherwise, I need to do the update of the current time in that dictionary, and of course, send the email. This is the code that I'm saying does not belong in the microservice. This is just a demo. I mean, it's constructing HTML. Basically, the less possible, I don't care how good of a developer you are, the more code you write, the greater chance there is for exceptions. End of story. The less code that you write, the less chance there are for exceptions. So there's, potential for exceptions. God knows where in here as I'm formatting some HTML. Down here, I'm doing some string concatenation. Maybe I'll get an object reference not set, type of thing. But, constructing the HTML message really doesn't belong in the microservice, but this is just a demo. And that is the email alert microservice. And you'll see that the other microservices are all very similar, right? Let's flip on back to PowerPoint. There we go. What about querying real-time flight data? We saw those planes moving along the map. How do we do that? How do we query that information? Well, we have that location container. It has, what I didn't show you. Get back over to the to the Data Explorer. And if you look at this location container and these documents that I was looking at, okay, how many documents do I currently have? I mean, right now the generator is not running, so you know, it's going to be a static value. So I've got 32 million, almost 33 million documents in that container. A nice large number, but really tiny in the grand scheme of things in terms of what we're able to support, right? As it turns out, I only have 2 physical partitions behind my container, okay, for these 33 million telemetry documents. And of course, when I run the generator, I keep adding to them, okay? So I have inside these 33 million, there are 12 documents in there that are the latest documents. And if I query for those, I'll be able to show the real-time flight information. And here's the query that does that. Select top 1 by flight number. So for any given flight number, if I want to know what the current location is, I can run this query. If I order by timestamp descending, obviously, and I do a top 1, obviously I'm only going to get the last one. What's the problem with that? I'm going ahead of myself a little bit. Obviously, first of all, it's a cross-partition query because we're partitioned by ID, so it's not going to be very efficient. And we want to present that live map like you saw, like I showed you, you know, with the tooltip and everything. You know, I want to show that UI goodness. So I showed the flight location map already, but we're going to watch it again a little closer. Okay. It's right here. The planes are suspended in midair right at the moment. I'm going to start them up again. I'm going to first of all turn off the 2 flights. Start up the generator again. And drop in the air. And I'm going to watch one flight. This one flight. Yeah, there it goes. It's entering the no-fly zone, in fact. I know it looks like it's trying to avoid it, but it's going to enter the no-fly zone. Yeah, there, it just did. So we're going to get the email alert and all that. But putting that aside, let's click on logs and look at this. Let's look at this query. There's the top 1 query that we were talking about. Trying to make it a little bigger. There's the top 1 query. And what you can see is that at least this client is issuing this query every 3 seconds. So every 3 seconds is that top 1 query. And that's just for this one flight and this one client. And the cost is 71 RUs. And you're saying to yourself, is that a lot? Is that a little? Let me tell you, there's a lot. And it would be a lot more in a much larger container because this is a cross-partition query. And all I'm supplying is the flight number. And it has to find the latest one across a mountain, right, of voluminous amount of data when we really only ever care about the most recent 12. Okay, so we'll continue letting that run. I mean, you can see the RUs are like accruing pretty rapidly. If you want to see kind of insanity, I'll do all flights. Which now we're running that same query 12 times. Come on, did you get it? There we go. Now it's running the same query 12 times every 3 seconds as these planes fly. And now look at the cost. 3,400, 4,300, 5,100. I mean, it's really accruing at a rapid rate and not a good situation. Let me pause the generator. Just pause it. Now. We're going to talk about materialized views. So to get the current location, continuous querying that we were just doing is a very expensive operation over that mountain of location data using cross-partition query each time. And that's one client on one flight. The answer, you build a materialized view. It's a tiny view. We're going to have a container with only 12 documents in it because we only have 12 planes in the air at a time. And those are, and we only care about the last, and that's all we care about. Right, the most current one. We're going to partition this container on type, and they're all going to live in one logical partition. And then our microservice, when it picks up every document and keeps the most current one and upserts it, if you will, update or inserts it, it will change the ID from a GUID to the flight number. So you can query on flight number efficiently by the ID, when the type will always be current location, because we're going to partition on type and set every document to current location. It's going to be really cheap. How cheap? Let's get those planes flying in. Let's look at the logs. This is the current situation. I just cleared that out, so just let that go down to 0. Okay, 800 RUs, 1700 RUs, 2500 RUs. Not good. Let's go to the location map and check use materialized view. Go back to logs. Cost. Oops, 1 second. Sorry. Let's go with one flight. Logs. Cost. Whoa, 1 RU. That's cheap. Right, that's what you're after. Because we are reading from the materialized view, which is lagging slightly behind the real-time information, but only very slightly, and serving that information in near real time at a cost of only 1 RU per flight. Before we look at the code, this is costing, like, the RUs are only up to 10. Every 3 seconds it costs another RU per flight. So if I choose 2 flights, obviously it is now 2 RUs every 3 seconds. So it goes from 2 to 4 to 6 to 8, right? Because I'm issuing 2 point reads. I'm not issuing a query. And that costs 1 RU. So that means 3 flights would be 3 RUs every 3 seconds, right? Good. 3, 6, 9, 12. That's correct. But guess what? If I go with 4 flights, it's not going to be 4 RUs. It's not going to keep going on 1 RU each. Because my code is going to be smart enough instead to issue this kind of query. To select where the type is location and the flight number is in and supply the desired flight numbers at a cost of under 4 RUs when I'm looking for 4 flights. Because that's a single partition query, 1 query giving me 4 documents at a cost of under 4 RUs. Which would have been the cost if I did 4 individual point read operations. And of course, 12 individual point read operations would mean 12 RUs every 3 seconds. But using this trick, now I've got 12 flights. The in statement here is listing all 12 flights. Look at the cost, 4.47 RUs. And if I go back to the location map, just in case you forgot how bad it was before, look, it's accruing really slowly. Very inexpensively. Turn off materialized views, go back to the way it was before. Bam, you're back to 860, 1700, another 3 seconds, and that's just a single client. So let's have a look at the microservice. Let me pause the generator. We're getting really close to the end of the session. Just jump back to Visual Studio. Okay. By the way, I also meant to show you at the outset that I have this Azure Blob Storage container. Okay, I haven't hit refresh yet, so it still looks empty. I'll hit refresh in a moment. This flight history container, I emptied it out before the start of the session. This is Azure Blob Storage now, because one of our microservices has been writing to you this container, but I haven't hit refresh yet, so you don't see it. Good. So let's move on now to the current location microservice. First of all, let's look at the current location container. The microservice has been writing through this container, and this container has how many documents in it? 12. That's it. Each one is the latest. And the type set to location. The ID was changed from a GUID to the actual flight number. So because we're partitioned on type in this container is partitioned on type. You can see that here, sorry. There, the partition key is type. But for that reason, I can query for a flight. I can do a point read because I know the ID and partition key of the document that I want, the ID being the flight number, the partition key always being the word location. If I want to do a point read, and if I want to do a query to pull back 4 or more, because it's more efficient than doing individual point reads, that query is still going to be contained to a single logical partition, all of them being in location. So that's cool. And how do we do that? The microservice first, and then the querying code. Here's the current location microservice. Local settings JSON, unique port number, right? 7072, so we can debug concurrently. Same pattern. Go to a Cosmos client, which we need, but the same concept of timestamps, because we don't need to update that current, updating that current location container every 10 milliseconds is needlessly expensive. I mean, it's just needless. You don't need to do that. You can throttle it. We're throttling it. I'll show you in a moment. But it's the same pattern, function name attribute, CosmosDB trigger attribute. We're watching the location container. We're using the lease container for state for the CFP library, but we're uniquely prefixing the documents in that container for this microservice. We're getting the documents. We are looping through each one with a try catch, updating the current location container each time. The same deserialization as before. But should we skip it? Because like I said, we're going to throttle. So let's look at should skip. Should skip. If the location event is complete, the plane has landed, we cannot skip this event, even if it's been less than 3 seconds. Otherwise, it's okay to update our real-time current location container every 3 seconds. That's fine. It doesn't have to be every 10 milliseconds. But we do not want to miss this event. So if is complete is set, then we don't skip it. We never skip it. Otherwise, we enter a similar thread lock for the thread safety around the access to that dictionary. Throttling every 3 seconds, skipping if it's been less than 3 seconds, otherwise not skipping it. And if we don't skip it, like I said, it's super simple. This is the logic of the microservice, those 2 lines. That's fundamentally the logic. Take the ID that was a GUID, set it to the flight number, which you have in the event, and upsert it. Upsert means just that, update or insert it automatically. And the partition key value is always location. On the client side of things, in the desktop app, well, in the interest of time, I'm just going to go down to the data access code that the desktop app is calling, and that's in flight repo, in the interest of time. Without that checkbox checked, not using the materialized view, the expensive version of the query, here's the select top 1 query. That's what we were calling. And that's what was costing 70 plus RUs or more, right? But if it's a point read, you won't find, like in this case, if you check the checkbox, it'll be a point read. And in that case, you don't see a SQL query here. You see a call to read item, and you pass in the ID, flight number, and the partition key location. And that's it. And the charge should never be more than 1 RU if the document is under 1K. If the document is over 1K, it might be slightly over 1 RU. Okay. But I have logic up in the front end that says if the user checked 4 or more flights, then I shouldn't issue a point read for each one. I should do that query with the in, right? But still, I know what the partition key is. It's the location. And again, very inexpensive. And that's the current location microservice. We're going to kind of wind things up. I'm going to lump the last 2 together, because I'm definitely not going to get into the code in this case. Well, why? Sorry. Okay. I'm not going to get into the intricacies of this code because it's a little more sophisticated. But at a high level, what we're doing is we have another microservice. It is what ones were. It's getting the current telemetry. And it is querying the remaining time for each flight in the air. And it is grouping. It is maintaining a view in memory, in fact. And again, thread safe in a thread safe way, in order to produce a materialized view with documents that look like this. So the flights are grouped by airport. So each document is for an airport. This is the LAX document. The materialized view is producing this as in real time. It is the events are streaming in, and every few seconds it will upsert a document for each airport. These are the flights arriving in LAX, where they departed from, and what the remaining minutes are on those flights. This is for Seattle. This is for Orlando. That's the idea. And the very last demo, which is the last scenario that we had, which was moving data, you can do to replicate to a secondary data store and feed data to any downstream system, for example, SQL database. But in our case, we want to archive to cold storage. We'll use TTL, like you saw, for 30 days, so that it expires out of Cosmos DB a month later, which is well longer than we need it to sit around in Cosmos DB, and store it in either blob storage, data lake, and in our demo it'll be blob storage. Okay, so let's look at both those. I think we'll do the code first this time and then the demo. Why just to mix it up. This is the arrivals board microservice. Don't worry if it seems like I'm going kind of fast here. I said I wasn't going to get into the intricacies of how the arrivals board dictionary is actually maintained. But if you look at the privates, there's our standard Cosmos client. This is the arrivals board. It is a dictionary keyed by airport. And the value is a list of flights coming into that airport. That's the dictionary that we're upserting. This is what we're using for concurrence, for throttling. We don't need to update the arrivals board similarly like the other microservices every 10 milliseconds. And this we're using for thread safety as well. Our familiar function name, our familiar Cosmos DB trigger. We're watching the location container. These are the documents that have changed for each one. We deserialize the object into that strongly typed object once again. And this just extra bit of code here is just to make sure we don't miss that is completed event, which occurs only once when the plane lands. Is complete, right? And we call update board with each one. And the board has to be updated with each event, but that's an in-memory dictionary that we're updating with each event. But the document doesn't need to be written to the materialized view with each event. That can be throttled for, what did I set it for? Should skip like before. Should skip every 5 seconds. Every 5 seconds, we'll upsert the arrival information from the real-time in-memory dictionary, right? Make sure not to miss the latest one. So you don't want to skip if the documents include completed flights. You definitely don't want to skip it. Otherwise, you throttle every 5 seconds. Updating the board, which happens with each event. This is the code that I said not going to get into too much detail about, but inside this thread safe block of code here, we are maintaining that document, that arrivals document. If it's the first time for that airport, we'll new it up, and there's going to be an array of flights within each one of those airport documents. So that's the code there. But in terms of writing to the materialized view, that's only going to happen every 5 seconds. So if you shouldn't skip, this is what updates the materialized view every 5 seconds for each airport in our in-memory board, keyed by airport, upsert the item. That's it. Let's look at, and that means that on the client side, again, it's going to be very cheap. Let's look at that code. When we look at the arrivals board, where was it? Site repo. Yeah, read airport arrivals. Given an airport code, it's just a read item, no query. It's a point read, a cheap query. 1 RU if it's under a K, which it is. So let's see, let's watch it. Let's get our flights flying again. Now the generator is running. And let's go back to the front end. Where'd you go? There we go. I'll clear that out. And let's stop with the location map and let's just switch to the arrivals board. And let's just look for the flights coming into JFK. Okay, these are the 2 flights coming into JFK, 6:59 and 6:55. Oh, looks like they're coming in sooner. I told you my planes fly real fast. Each time you look, they're just coming in sooner and sooner. But there's your real-time arrival information. And what's the cost? 1 RU every 3 seconds for 1 airport, And, 1 one airport is only going to show the flights coming to that airport. But if this was some app that was querying for all the airports, about 1, 2, 3, 4, 5, 6 airports, that's 6 RUs. Oh, actually 4, because 2 of them don't even have data. I have to find out if it's costing 1 RU or not, those 0 RUs. But you see, it's very inexpensive either way. So that's the arrivals board microservice. And finally, the last one, that data movement microservice. This is really simple. It's basically, again, by throttling, not copying every single document, but every so often, copying or archiving a copy of the flight telemetry to Azure Blob Storage so that it remains there permanently after it expires out of Cosmos DB with TTL. And so that takes us to our last microservice, which is the data archival microservice. And we've got our familiar dictionary for throttling, an object for thread safety. This is an Azure Blob container. And if you've ever done any C# code against Azure Blob Storage, this is going to look familiar. So the Azure function itself looks like all the others, except this time it's the lease container, the same lease container with a different prefix for this microservice. We're looping through each document. We're going to try with a try catch. We're going to call archive. We're going to check, should we skip? After we do the deserialize, should we skip? Just like you've seen before, we don't want to miss when the plane lands that event. We'll want to make sure we archive. Never lose that. It'll be in blob storage forever. Otherwise, every 15 seconds is adequate to archive a document to blob storage. All the other documents will just, live in Cosmos DB for 30 days and be gone forever. But every 15 seconds, we'll be able to, see the 15-second interval history of every flight forever and ever, and ever and ever. As long as blob storage doesn't let us down, right? So if we don't skip it, then, like I said, this is code that should look familiar if you've done any Azure Blob Storage. If you've ever read from or written to blob storage, it's code that looks just like this. There's a blob reference, and you get the bytes, and you upload them, and blah, blah, blah. No fun intended. Blah, blah, blah. And that's it. So if we flip on over to the pour it one more time. And now I refresh this. There you see a bunch of documents that every 15 seconds, and there's the file name. In our code, we set that file name like this, .json. That's what all of these files are. Can I look at one of them? I should be able to look at one of them, right? Download. Yeah, this is a problem with this Storage Explorer preview. Let me flip over to the old Explorer. Flight history. There we go. Come on. I think I can look at it here, right? I can look at it here. Well, if this doesn't speed up, there we go. Download. Yeah, this one works. There we go. That's why it's still in preview, I guess. I just downloaded it. Here it is. I'm just opening individual studio. This is from blob storage, but this is a copy of the document that was written to blob storage. Right. So there you have it. The last thing I wanted to show you, which I promised at the end, I would show you the lease container. You normally don't have to go in there, but just to appreciate the work that's being done for you by the CFP library, which you would have to do yourself if you were directly querying the partitions. You were on your own discovering the partitions, and for each one querying those change feeds. Not fun, but inside the lease container, you'll see I've got a bunch of documents here. There's actually 3 documents per microservice. Each document is prefixed with the name of the microservice, so that prefix that I specified, which allows them to share the same lease container, yet independently maintain a timestamp for an individual partition. I actually have 2 partitions. Why are there 3 documents? Because you get 1 document per partition plus 1 document for the whole microservice. So that's why there's 3. This one's for partition 2, saying that letting the CFP library know internally that partition ID 2 was last queried at this timestamp. And that's that one. And this one here should be for partition ID 1, I'm guessing. Yep. For this partition, it's got its own timestamp within this microservice. And this is the one for the current location microservice itself. It needs 1 document for itself. So there's 3 per. And there you have it. That's my presentation, folks.
That's awesome, Lenny. I love it. That's just you tell a ton of time and effort went into it. If I had one nit to pick, it would be that flights going into JFK should show up later, not earlier than scheduled. I think would be just to keep it more.
We're working on that.
Or maybe or just not show up at all. Canceled.
I'm going to bring that up with our customer service reps.
So I've only got one question. Well, let me get a comment from Sergey. Just love your demo. Love the throttling logic. That's definitely that's some cool stuff you got in there. Question from Melon Dev.
Yeah.
How does Azure Functions work when you have a large amount of change feed events? Does the change feed reader scale across multiple nodes?
Question. That is a great question, because clearly if the change feed reader would scale across multiple nodes, an in-memory dictionary for these processes would not be adequate. We would need some sort of external mechanism there. I have to confess, I don't know the answer to that. I don't think it does. But Mark, maybe you know better.
No, it can only scale across physical partitions, because that's basically where those things sit.
Right, but is my code that is multi-threaded, that is written to be thread safe because there's multiple instances being parallelized across multiple partitions, is that code all running on one machine, or can that code also scale to run on multiple machines? Is the question.
So when you scale, that's kind of interesting. So I could run. Let's just say I have 3 physical partitions. I can run one of them, and it will read from all 3 physical partitions. However, if I want to parallelize, I can add instances, and there's nothing to stop you from running. Let's say I have 3 physical partitions. I can create 5 instances, but 2 of them are going to sit there and do nothing, right? So you have a limit to how much you can scale out, and that is the limit, and that is the number of physical partitions.
Yeah, but if your code could run concurrently, then your microservices need to scale to that degree. Then you need something like Redis cache or some sort of caching mechanism that could be shared by all the nodes to maintain concurrency.
You could run change feed pull and then write your own.
Yeah, but you don't want to do that.
Sure. I got all day. Sure. Let's see. Question, comment.
Can I make the code available?
From Dale.
Yeah.
Great talk.
How can I make it available?
You got a URL you can hit me in the private chat?
I do. I'll share it with you.
Put something in the private chat there.
I don't have it now.
Oh. You know where you could put this, Lenny, is on the
You know what? I'm going to put a link in the chat to this same presentation from another time, which is same code and slightly out of date deck, but pretty much the same, pretty much identical content. The only thing it doesn't have is that new slide on the full fidelity change feed. Otherwise, it's the same deck and the same code. I'm going to post that link right now if you give me 30 seconds.
Yeah, sure. Why don't I share? I think it's time for us to do our drawing here. So I'm going to share my screen and giveaway tool. Share. Okay, so we've got 7 entries in here. What I will say is if I call your name, if you don't have my email address, just DM me on Twitter. I am at Mark J. Brown. Or even if you have my email address, you can still DM me. That's fine. And then I will reach out, get your contact information, and then ship you one of our newly fangled neoprene drink coasters, of which I have a, whoops, how am I doing this? Box of those. And I will also send you one of our Cosmos DB fancy stickers to put on your laptop. Alrighty, so let's do this. Let me do a drawing here. So our first winner is this thing going to stop? Okay. All right. I don't know how to say that name, but I'm going to write you down. Okay. Congratulations. You are a winner. And let's do, we'll do one more because I promised we would do two here. So here we go. We're going to spin the wheel. This is quite exciting. I'm excited by this.
It's fun.
This is very fun. And Alec.
Hey.
Okay.
Alec.
Alec Lazarescu.
Me and Alec go back.
Okay, it sounds like it. Oh my gosh, Lenny, that's a OneDrive. Okay, I will put that in a banner.
Okay.
Well, people are gonna have to do a screen cap on this if they want to do it, and then type it in.
You mean like a bit.ly link?
Yeah, if you got one, that would be sweet.
I don't.
Okay, well, I'm gonna.
Sorry.
That's okay. I'm gonna let people make a screen cap of that, and then they can come get your thing. If you could create a bit.ly link and just drop it into the discussion for the meetup and on meetup.com, or maybe I can create a link to that.
Maybe I have a bit.ly link for you. Maybe I don't. I have to go take another look now. Boy, you're really giving me homework here.
I'm sorry. Yes, hosting user group meetups is
it's part of the deal, isn't it?
Yeah. Well,
I think I have one.
It's still easier than doing these in person, I think.
I don't know. Oh, man.
Although there's no pizza or beer.
Oh, yeah. Well, I'm heading out now for pizza and beer. So.
Oh, that sounds nice. I've got a meeting.
New York pizza. The best.
I haven't been to Manhattan and gotten some genuine New York style pizza in quite a long time.
Okay, I have one. It's from the San
Wonderful
platform.
Hold on. All right, let's get rid of this guy. I'm going to edit this and clean him out. Thanks for sticking around, folks. And okay, I see. Oh, that's much better, Lenny. Okay, let's put that back in here and save. Okay, folks, here you go. So I'll leave that up for a moment and people can screen cap or write that down. And I think just want to say thank you, Lenny. This was much smoother than last month's inaugural, I have to say. Teams was the Teams live, I guess, is what the challenge was.
Thanks for being our guinea pig to kick it off for the first one and get bruised so that the rest of us can have a smoother time. Appreciate that.
Yeah. Oh, just some interesting. Okay, more comments here. I guess people are seeing this on the back there. So, yep, fantastic. Wash hands. Yes. Okay, I think with that we will conclude our second user group. We've not yet scheduled our one for November. I got to check the sign up list. I think we've got one in there. I've got to go in and check and then get everything scheduled. So we'll get that happening soon here. Get that up on the Meetup board there, and you can get in there and RSVP for it. And that's it for us for this time. So thanks again, Lenny. Really appreciate it. And thank you everyone for joining us. We'll see you all next month.
Bye.
Bye-bye.